to get familiar with vSphere 8 innovations as well. So with that, I'm done. Okay, meanwhile, how many of you had a chance to play with vSphere 8, at least in the lab? Okay, I know, you guys. Okay. How many of you have heard about DPUs? All right. Okay, looks like we have a full house.
Yeah, we should start.
Okay, we can get started then. Okay, so vSphere 8 is one of the biggest releases we've had in some time. There's a lot of excitement in the field about vSphere 8. Even at Explore, where this was announced, I think a lot of customers were excited, a lot of partners were excited, and even the vendors whom we've integrated with when it comes to DPUs, I mean, they were more excited than us, right? So we're going to talk about some of those innovations in vSphere 8. And I'm going to keep it at high level, right? I'm going to keep it at 10,000 feet view. I'm not going to get into too many details because there's so many features here that we have to talk about, and we only have a limited amount of time. My name is Gurudatt. I lead the core vCenter part of the product management for vCenter. Along with that, I also manage some of the availability features within vCenter as well. I also have my colleague Ajay, who's part of the product management team as well. So I was just telling Ajay that this session and the next session, we are the two people who are standing between you and your lunch. Okay, so what I'm going to cover in the next few minutes we have in front of us is a couple of top innovations on vSphere 8. Some of it is already covered as part of the Tanzu session we had, and I think there was vSAN session which covered some of it. So I'll try and cover the kind of overview of some of these features, and then we'll see if you guys have any questions. The first one is vSphere Distributed Services Engine. So I asked initially how many of you heard about DPUs. There's a couple of people who raised their hands. So this is one of the biggest innovations on vSphere 8. Right, so Distributed Services Engine is all about DPUs, right? This in VMware was called Project Monterey in the past. This has been in the works for a long time. So we finally have something that we are taking it out to the market. So DPUs are essentially smart NICs, right? So smart NICs meaning they have their own CPU complex, they have an accelerator so that you can offload certain services to improve and boost the performance of those services. So that's what DPUs are. Again, this is not a new tech. This has existed in the hyperscaler world for a long time. A lot of customers who are using hyperscaler services have been benefiting from this, but you don't know it because the way it is consumed in the hyperscaler world versus the way you do it in an enterprise or a private cloud is a little bit different. Now, in the hyperscaler world, because they use a standard set of hardware, and then they only expose the services to you, you don't really know what they're using, and they don't run into the kind of challenges an enterprise customer will run into when they deploy DPUs. Now, as an enterprise customer, when I'm going about deploying or using a DPU, I have to worry about the OEM hardware that I am shipped with, maybe a Lenovo or HP or whatever hardware I choose. And then there's a DPU vendor, maybe an AMD Pensando, or there is a NVIDIA Bluefield that's coming up shortly, or an Intel DPU, right? So it is upon the enterprise VI admin or the architect to think about how to integrate this, how to make this all work. So what's the role of vSphere or VMware here, right? So VMware is playing the role of an ecosystem partner here, who is trying to use vSphere to simplify, abstract all of the hardware level complexities that you have and help you deploy these DPUs, as well as offload some of your services to the DPUs to make your performance better, to provide you that operational simplicity and security. That's the role of vSphere. So let's get into a few more details to see how this actually works. Now, today, without vSphere 8, DPUs live in the hardware layer, right? And then there is the x86 the ESXi basically sits on x86, and all of your services like NSX services, vSAN services, host management, compute, all of this live on the ESXi layer that sits on the x86. Right. So what we're saying now is with vSphere 8, you can offload some of the services that are running on that x86 to the CPU complex that is running on the DPU. So in order to do that, you have to have an ESXi layer running on the DPU as well. So that's the innovation that actually happened in vSphere 8, so that you can run an instance of ESXi on the DPU, on the CPU complex of the DPU, so you can offload some of those services onto the DPU. So what do you get by doing this? So now, by doing that, now the x86 resources that were there can now be consumed by your workloads to make your workloads perform better. Right? At the same time, because the DPU is processing some of these services, so your services that are offloaded to the DPU also perform better, they provide better observability, and also provide more simplicity. Right? So what are we offloading really in vSphere 8? In vSphere 8, we're offloading network services onto the DPU. Right? So the distributed virtual switch, the NSX services, which is your VXLAN, your VLAN segmentation, layer 3 forwarding decisions. And if you have firewalls, right, all those complex rule sets are all processed by the NSX that is running on the ESXi of the CPU complex of DPU. So a couple of things, it sounds very simple, but a lot of things went in here, right? So you had to rewrite the ESX code or introduce something so that it runs on the DPU complex. And then you had to re-innovate and write NSX code to make it work on the DPU. Right? So that's the kind of innovation that went in to make this happen. Now, this also brings in a few other capabilities that we can talk about here. Let me just move to the next one. So in vSphere 8, we're supporting only the greenfield deployments of DPUs. And the first one that we're supporting in vSphere 8 GA is Pensando, right? AMD Pensando DPU. Shortly, it's going to be exposed to NVIDIA Bluefield as well. And then there's going to be an Intel-based DPU as well. So one thing to keep in mind is not all DPUs are created equal. Right? So again, from a vSphere perspective, we're abstracting a lot of that. But when you think about the hardware itself, right? So not all DPUs are created equal. Maybe an AMD Pensando has different capabilities than NVIDIA Bluefield. So for example, AMD Pensando claims that the DPU chip that they have is a programmable chip. So what does that mean? Right? So today, when you talk about networking, so in data center, VXLAN is the preferred choice of encapsulation for segmentation, right? Today, earlier it was NVGRE or some other protocol that was used. Tomorrow, maybe there's something else. On the same lines, today there's IPv6, maybe tomorrow there's going to be something else, right? So if you use a chip that's not programmable, what that means is you have to respin that chip in order for you to support the next generation protocol. Whereas with this one, since it's a programmable chip, so even if today it is VXLAN and tomorrow something else comes up, you can just compile that code on the same hardware and still make it work. So you don't have to respin that chip to make it happen. So I come from a Cisco networking background. So I was a CCIE in data center and security. So I know quite a bit about hardware and how all of this switching stuff works. All right, so again, just to summarize, right? So what you get with this integration is, since your network traffic is all offloaded to the DPU, you of course can free up resources on your x86 CPU to run your VMs better, your workloads better. At the same time, your network performance gets better as well. You can get increased visibility and observability. Now, when you're running networking services on x86, there's a limit to what kind of stats you can export, what kind of visibility that you can get from your network. Now, because this is running on a separate chip, there are more capabilities that you get because of the hardware that's actually processing some of this network traffic. And then, of course, there is benefits on encryption, isolation, some of the protection capabilities that is offered as well. Again, one other thing, I don't think there's a slide to cover that, but I'm just going to cover it here, is you also get access to something called universal pass-through 2. So that is one of the other capabilities that comes as part of this as well. Now, if you heard about dynamic port IO and some of those capabilities which would use SRIOV, right, to improve performance, they would bypass the ESXi layer to give you performance of the bare metal. But again, the cons of it, or the compromise that you're making with that, is you don't get access to all the VMware goodness of HA, DRS, and all of that, but you get performance. Now, universal pass-through 2 that comes along with this, you don't make a compromise now. You still get the bare metal performance, but at the same time, you get VMware goodness of HA and DRS and all of those things. Okay, so that was one. I think I missed one more thing, so I'm going to talk about that as well. So again, going back to that previous slide, now the obvious question when you see that an ESXi layer is running on DPU and an ESXi running on x86 is, you get this question that I already manage the life cycle of ESXi that's running on x86. Now you're adding another overhead by giving me another ESXi layer on DPU that I have to life cycle. So how do I go about that? Now, VMware thought through this problem while we created this. So you don't have to deal with the overhead of managing two ESXi layers. So what we do is, as part of VLCM, you can remediate the one that's running on the DPU the same way. It's managed at the parent host level. So you are not exposed to the details of this ESXi layer that's running on the DPU, and the version is kept in lockstep with the parent host version, parent ESXi version. Okay, so next one, there's a couple of enhancements that we made with vSphere with Tanzu. I think Vikas already kind of covered some of those. So the first one is unified Tanzu Kubernetes grid, where we are now unifying or consolidating our Kubernetes runtime so that the single Kubernetes runtime that you can use across public cloud and private cloud. And then there is vSphere zones that you already saw a demo for, which was focused on workload availability zones, where you can kind of span your workloads, namespaces, supervisory clusters, etc., across vSphere zones, so that you get increased availability and isolation from failures. And then there is something called declarative cluster lifecycle with cluster class. This is a cluster API project, open cluster API project. So what this does is, using the management cluster, it helps you deploy a consistent config at the cluster creation time. And as a platform admin, you can actually add some packages that go along with this as well. So that's what the cluster class is, or cluster API project is. And then there's a couple of other enhancements. The most important one is the Pinniped integration. So I'm going to talk about that in just a bit. So again, this was covered, so I will not go into a lot of details. You saw a demo for this as well, which is the workload availability zones. So we have a concept of vSphere zones that you can create. And then, as you can see, your namespaces are spanning across the zones. Your supervisory cluster is spanning across the zones. And then at the workload activation time, you can choose to deploy your workload on a single cluster or across multiple clusters that is spanning across the zones. So this provides increased availability and isolation from failures as well. Okay, and this was the cluster class or cluster API project that I was talking about, which helps you deploy a consistent configuration on all of your TKG clusters from a supervisory cluster when you're talking about VMware vSphere with Tanzu. And you can also, as a platform admin, you can add multiple packages that go along at the creation of the cluster time. So another important thing that went into vSphere 8 is flexible package management, where using your familiar Tanzu CLI, as a DevOps admin or a developer, I can add additional packages. For example, if I want to do certificate management, if I want to do logging with Grafana or some of the other tools, I can add them as additional packages, and then they can be consumed using Tanzu CLI. This is another important integration. So in the past, in vSphere 7, the only way you would kind of authenticate with the supervisory cluster was using vCenter single sign-on. So that is an option that still continues to exist, but you have an alternative. The alternative is this Pinniped integration, which is an external integration that you can use now. In Kubernetes world, Pinniped is known as one-stop shop for all authentication needs, right? So that's what people usually call that. So that's the integration we now have. The key point is, you don't have to use the vCenter single sign-on now with this integration, even though you can choose to if you didn't want to use this. Okay, moving on to lifecycle management. The first one, I kind of already spoke about it, right? So you have two different ESXi layers to think about now. How do I manage lifecycle of the DPU? VLCM handles that today. It remediates the parent ESXi host, and that also takes care of the ESXi that's running on the DPU. And it ensures that the version is kept in lockstep with the parent ESXi host. So the next one is staging support. I'm going to talk a little bit about that. There is a couple more things. The most important one is parallel remediation. So let's touch upon that. So before that, there were a couple of people who said update manager is still my favorite because it's so simple to deploy, right? It's going away. So the company has decided that we're going to invest in lifecycle management. So VLCM is the next generation update manager. So whatever goodness that you find in update manager, there is going to be feature parity between update manager and VLCM. So in the vSphere 8 version, you will see this banner that says, your update manager will be deprecated soon. Right? So in the coming release, you'll not find vSphere update manager. So there's only going to be VLCM. Okay, so one important feature we added as we are kind of building that parity with update manager is staging support. Now, when you have your update payloads or upgrade payloads, right, you can now stage them before you remediate. So when you say remediation, you basically are going into maintenance mode, right? So in order for you to avoid longer times during maintenance windows, you now have a way to stage this before you actually put your host in maintenance mode. So along with this, you can also manage the firmware payloads, right? But again, keep in mind that with firmware payload staging, you need support from the hardware support manager as well. So the VMware, vSphere compatibility guide actually has a list of VLCM features that are supported with HSM. Okay, so the other important feature is parallel remediation. We have significantly increased the number of hosts lifecycle management can now manage with vSphere 8. Now, along with that, another the critical feature is you can parallelly remediate multiple hosts at the same time. So once you place your host in maintenance mode, so you can choose whether you want to remediate all of the hosts at the same time, or you can put a number in there that says, okay, remediate these many hosts in parallel. But the key is these hosts have to be in maintenance mode before you can remediate them in parallel. Okay, so if you have any feedback on this feature, I can personally take it because I am the owner of this feature. Okay, so it's called enhanced recovery of vCenter. So internally, we call this Project Bajos. So today, let's say you take a backup of vCenter, right? And then once the backup is taken, somebody goes and changes, adds a new cluster or adds a new host to a cluster, or maybe does some new networking configuration, right? But your backup is old. Your backup does not have these changes. Now, let's say there's an outage on vCenter and you choose to restore your backup. You're losing out on all of the changes that you made after the backup was taken. Right, so this is an issue that we found with a lot of VMC deployments and also on-prem deployments, but mostly VMC. So we decided to solve it both for VMC and on-prem. So what we did is we built this distributed key value store, and this is sitting on the ESXi host or the cluster, right? Now, this keeps track of all of the cluster host membership changes that you're making to your cluster. If you're adding a new switch configuration, VDS configuration, or if you're adding a new data center hierarchy or a folder, right? So all of that is basically stored on this DKBS. So when a backup is restored using your old backup, now that there's a state mismatch between what the ESXi cluster is saying versus what vCenter has, so this cluster store or DKBS is synced with the vCenter. So vCenter has the most current data. So that's the innovation with enhanced recovery of vCenter. So today in its very first release, which is 8.0, we are only sort of reconciling cluster host membership changes. So very shortly in update 1, we will also do networking configurations, certificate configurations, some of the HA config, and then folder and data center hierarchy as well. So these are all coming, but right now it is only cluster host membership. Okay, so this is the same stuff that is being showed with some animation. So I just spoke about it. All right. Okay, now you all know that VLCM is replacing Update Manager. So what's replacing host profiles? How many of you are fans of host profiles? Okay, now we are working on a next generation host profile that's called configuration profiles. So in vSphere 8.0, this is tech preview. You've not released GA yet. So this will go GA in the next release. So this is based on the desired state configuration model. So you can define a desired state config and then deploy it at a cluster level so that all of the hosts in a cluster have consistent configuration. So you can use like a reference host, store the config in a JSON format, and then you can say, okay, this is a consistent config that needs to be deployed across all hosts. There is some unique config that only needs to go on a particular host. So all of that can be managed on that reference host config, and then you can deploy it across the cluster. Now, this also has the ability to do config drifts. Now, once there are config drifts, a VI admin can go and remediate them. So all of that is the functionality that we have on the config profile. So like I said, this is a tech preview. In update 1, I think we will go GA. And then the decision on when host profiles will go away is yet to be taken. So host profiles will still continue to stay some time along with config profiles. Okay, AI ML. Again, I spoke about Project Monterey earlier. And we spoke about it from the perspective of DPUs. There's also GPUs, right? I mean, we had a lot of work that we did with GPUs in version 7, so that we can simplify and help customers deploy AI ML workloads with the operational simplicity that we can think of. Right. So there is a couple of enhancements in 8.0, and those 8.0 enhancements are related to device groups. So what is a device group? So if you have complementary hardware, such as GPUs and NICs, right, you can group them as a device group and discover them as a group at the hardware level and present it to the vSphere layer. So that's the idea of device groups. Now, as you can see, what can form a device group? So if you have a GPU and a NIC, and if these are connected to the same PCIe switch, right, so they can form a device group. Similarly, there's a GPU and a GPU, and there's an interconnect between the two GPUs, and they're connected to the same PCIe switch. So they can form a device group. Now, these are discovered at the hardware level and then presented as one single unit to vSphere. So as you can see, the animation there, so those are the device groups. Now, once a device group is discovered, the workflow is very similar to adding a new PCI, device. That's the same workflow. And then with this device group that is discovered, when you use DRS and vSphere HA, they are aware of these device groups, and it takes care of appropriate placement based on this device group. So there you go. So it is actually showing you how the placement decisions are made or how the device selections are made. So another important thing that we did was with device virtualization extensions. I kind of spoke about this from the context of universal pass-through earlier. So with direct path IO and dynamic direct path IO, the challenge was the devices that were, the VMs that were using this, right? So we had some challenges with vMotion in the past. So, you could not suspend VMs, you could not resume VMs. So all of those were different challenges that you had. So now we are addressing those with what we call as device virtualization extensions. So in order for this to work, it needs a compatible DVX driver on the ESXi host and a compatible virtual device on the virtual machine as well. So once you have that, see how the vMotion happens. So vMotion automatically happens to another ESXi host that supports the same DVX driver and virtual device. Okay, so this is an enhancement over dynamic direct path IO. Okay, moving on. I have, I think, 2 or 3 more sections. The next section is guest OS and workloads. So here we talk about some of the virtual hardware related enhancements. The most important one is this one, which is the virtual TPM provisioning policy. I'm not going to talk about each one of these, but the most important ones. So on the slides, I think you'll still have some of these that can be accessed later on. Okay, so with virtual hardware version 20, what are we getting? So the next slide has a list of innovations. So for example, we're getting the latest Intel and AMD CPU support. I already spoke about direct path IO. We're supporting 32 direct IO path devices. Then on the guest services section, I think the most important one is this one, application aware migrations. There are certain applications such as VoIP applications and HA applications, right, which do not take vMotion very well. So how can we kind of enhance the experience of these applications so they can react to vMotions better, or they can adapt to vMotions better? So that's what this application aware migration is all about. And then I think we already touched upon device groups, and we now support 8 vGPU devices with performance and scale, and that's a constant improvement that we keep adding with every release. Okay, so this one, when you deploy Windows 11, right? So Windows 11 needs a virtual TPM, so that's kind of mandatory. And what happens when you clone a machine? When you clone a machine, the vTPM secrets also get cloned. And that's not a security best practice exactly, right? Because the vTPM needs to be unique. So what we've done with vSphere 8 is we've added an additional advanced setting that you can use, so that each time you clone or replace a Windows 11 machine, the TPM is automatically refreshed, or like a unique vTPM is created. So yeah, I was talking about certain time-sensitive applications, voice-over IP applications, and clustered applications that don't react to the stunts of vMotion very well. So they don't like suspend or gracefully restart services, or they don't fail over to another host in a clustered application case when vMotion happens, and this can lead to like bad experiences with the app itself. So what we are now doing is in vSphere 8, we're adding certain notifications within the vSphere vMotion framework, and these notifications can be consumed using VM tools by these applications. They can even respond to these notifications, so that if they work around those notifications, they can then, for example, restart services gracefully when a vMotion happens, or in case of a clustered application, it can fail over to another host when the vMotion happens, or it can delay till the config timer is configured so that it can delay that migration. So some of those things can be done using vSphere vMotion notifications. Okay, I'm not going to cover the hyper-threading in the interest of time. Okay, from a scalability perspective, right? So we now support 96 hosts per vSphere lifecycle management cluster. That's what I said earlier. And then there are increased vGPU resources. I think the next slide actually has the full picture, right? So where are the changes? The changes are in vGPU per VM. There's also an increase in VMs per cluster, and then the direct path IO devices per host. So these are some of the scale and performance improvements on vSphere 8. Okay, this was all covered, so I'm not going to cover this again. Okay, resource management, right? So anybody familiar with this one? vSphere memory monitoring remediation, MMR? So there's a version of this that already exists on vSphere 7 that gives you metrics on like the memory, right, at the host and the VM level, the bandwidth and missed memory rates and things like that. And now we are enhancing that. We're calling it vMMR2. There is some enhanced stats that you can get on the memory usage, reclamation, and all of that, that can help DRS make optimal placement decisions based on memory. So that's the use case here. And then the other one is from a carbon emission perspective. So we're calling it the vSphere green metrics. So we've introduced 3 different metrics, as you can see here. There's one for power capacity, usage VM, usage system, and usage idle. So what this means is, the first one is for all of the power and energy that you consume when there is VM activity on your host. The other one is when the system does not have any VM activity, and the third one is when the system is idle. So you can then consume all of these metrics on the VMware ARIA Operations Manager, which can then make predictions on like carbon intensity and emission rate and all of that. I think I have 1 or 2 more slides, and then our friend is going to start talking about vSphere Plus. Okay, from a security perspective, I spoke about the TPMS, the Windows 11 stuff that we did, right? The TPM stuff. And then with Windows 8, TLS 1.2 is a standard. However, we still have to take care of older operating system, which means we will still support the older TLS. And then you cannot run untrusted executables anymore on ESXi host. Until it comes from a signed source, you will not be able to run them. And with SSH timeouts, usually SSH is recommended only when you're doing some troubleshooting with GSS or whatever. But then usually what happens is we forget to disable SSH. So now automatically there's a timeout that disables SSH after a certain time. And then of course there is a hardening guide that we publish. So that now publishes more secure product defaults that you can find on the security hardening guide. So that's the security configuration guide. That's the link. So with that, I've kind of given you a 10,000 feet view of the key innovations that were delivered as part of vSphere 8. Right? So you have this YouTube channel that our technical marketing team works on that has videos and demos of all of the stuff that I just spoke about. I actually wanted to run a demo of how to run ESXi on a DPU, but I just figured that the same demo is on this channel as well. And the demo that I have does not have audio, so I'd rather you can just go to this vSphere channel and see that video. What else? I think this is all familiar stuff. Maybe you guys already know about where we put our security advisories. And all our technical resources, right? So for example, you want KB articles and you want some of the technical guides, all of that is available on this page for vSphere 8. There's also a hands-on lab environment that you can use to get familiar with vSphere 8 innovations as well. So with that, I'm done.